Right at the beginning, does this replace Deep Sky Stacker then? You can stack your images and everything with this?
Yes, it does. It goes right from your raw images. It will debear them, stack them, calibrate them, the whole bit.
Okay.
That's again under the special functions tab. Oops, sorry, image set tab. Yeah. This guy right here, automatic image set processing. Okay. That will do everything for you automatically. You just throw your images at it, tell it what you want it to do, click go, and go have coffee.
Now,
or if you're like me, you do that when you get home and then you go to bed and get your image in the morning.
There's one spot there, processed AVI files and stuff. Will that like maybe replace Registacks type thing?
Not Registacks. What that does, that lets you process video files.
Okay.
ImagesPlus will do video for planets and that sort of stuff as well. It works. It's not the best for it. There are better packages out there, but you can produce very nice planetary images using Lucky Imaging with ImagesPlus as well. Problem is you have to record your files in a very particular format, simply because it was the one format Mike was familiar with when he wrote the code. I generally tend to do most of my planetary imaging using PIP and AstroStacker. Both of those applications together produce very nice images. And then I take them into ImagesPlus for all the stretching, sharpening, and that sort of stuff. Okay, any other questions on M13 before we move on to an M8 image?
We have time for a real quick beginner question.
Go for it.
You keep saying stretching, which I've heard people talk about, and obviously I'm not understanding what the term means. To me, stretching would be like blowing the image out left to right or up and down.
You're thinking physical stretching, yes.
Yeah, so if you could just explain what stretching means in this, I can see what it's doing, but I don't understand why it's doing it.
Okay, sure can. Stretching means, in this case, brightening. Now, what I'm going to do, I'm going to go back to the original image that we loaded up here. Bear with me a sec. That was... Okay, so there's the original image. Here is the histogram for that image. You can see most of the data is all down here. This is mostly noise and a couple of the bright stars that are saturated, like that one, and a few others show up here. Now, before I go too much further, are you familiar with the concept of a histogram?
Sorry, no, I'm really not. I'm a beginner.
Okay, that's no problem. In this case, it's not an image processing thing, it's a statistics thing. What you get here is the pixel value. So what I mean by that is, here is a pixel value of, I'm gonna quote this in an 8-bit level simply because the number is easier, 55. The vertical distance up is how many pixels on this scale that are at that value. So in other words, right here, we have some number of pixels at the value of 74. I'm dying to put my finger and point that out on the screen, but it doesn't do you any good, I'm sorry. And if I move the mouse, the 72 that I'm talking about disappears. The numbers I'm referencing are showing up right here, by the way. So you can see most of this image is dark. It's down here at a value of 1. Looks like Carl has just joined us. There we go. So what stretching means is you're stretching the histogram. I'm stretching this dim area of the histogram to cover more of the histogram. What that does is it brings out the faint details. So when I do that, I'm going to use a simple curve adjustment here. And I'm going to stretch the bottom, if I can get that handle, the bottom part. And you watch the histogram. You notice it started to stretch upward and got a little wider here.
Yep.
That's what stretching means. It's actually a histogram stretch. That's where the term came from. And that effectively brightens an image.
Thank you. I appreciate that.
No problem. You will find image processors always refer to anything that brightens an image as stretching the image. They're not talking about dimensional stretching. They're talking about the brightness histogram stretching. So you can see we've gone from an image that had very crappy background and a lot of noise to a rather nice globular image, right? We got a decent globular cluster out of it. The stars aren't blowing out. They haven't gotten too big. They haven't bloated too much. We could reduce them a bit if we wanted, but I'd sort of like that kind of more natural look there, and I'd be tempted to leave them at that. So let's move on to another image now. This image is M8. This is an image taken at St. Croix. Oops, that might be the wrong one, sorry. I have two of them in there. No, that was the right one. There we go. So here's an image of M8. This image was captured at St. Croix, stacked. It definitely has some saturated stars, as you can see, and they show up in the histogram. If you look at the histogram here, you can see this peak here. That's all those saturated stars. You will also see in most of the images we've looked at tonight, this is the sky background, the peak here, and you'll notice it doesn't drop right down. It actually sort of tapers off. That's a function of the stacking artifacts. I dither my images, which means I move them slightly between images. It helps keep noise down, but what it does is it produces black edges around the image, and that's a lot of this here. The actual image, when we're done, I would crop, and then this would come down at about this point. So here's this image of M13. Now we're going to do a couple of things with this image. Very first thing we're going to do, we're going to use an Arcsine Stretch again. So 1 second before I do that, I'll shrink this down a bit so I can fit it on the display for everyone to see.
Blair, is there any advantage in cropping first before you do the stretch?
Not really. The only real advantage is the stretch would be ever so slightly faster because it didn't have to deal with as big an image. I tend to work almost with the full image until I'm ready to do the sort of final crop and sharpen. There is no harm in going the other way, however, except you don't know where the stuff is until you stretch it. If you're using PixInsight, you have a screen stretch, and there you would know where it was beforehand. So what we're going to do now is slide this power slider over. So remember, now we're setting the Arcsine curve, and that alone will bring up most of M8. You'll notice again the background is all clipped. It's all very, very dark. So we're going to bring the background up a bit with the background weight slider. And now you start to see some of the faint stars and some of the gas and dust around M8. Now, a couple of things have happened. We're not done yet with the stretch, by the way. You'll notice that the bright stars are beginning to bloom a bit. They're getting bigger and bigger. And if you happen to like bloom stars in an image, perfect, you're done. I don't, so I tend to try and suppress the stars a little bit. However, we'll get there in a minute, because I'll show you how to do that in a few minutes. Now what we're going to do, we're going to try and take the dim parts of the image up a bit. So again, we'll go for the root X stretch. Carl was in the waiting room. Okay, here we go. So Carl had to log back in. By the way, Jerry, now you can clearly see the stacking artifact at the top. You can also see it along the sides and the bottom ever so slightly. So now what we're going to do from where we're at, we're simply going to brighten the dim stuff in the image up a little bit. There we go. Maybe just a little too much.
Blair, when you're talking about the stacking artifact and you said you'd like to shift your images, do you mean you shift the scope with time you take the image?
No, yes, exactly. It's all done automatically with the guiding software.
Pictures, put them together to make a.
Oh, Carl, are you trying to talk to us there? Assuming you are, you have to turn your mic back on.
I just saw something that Jordan said.
Oh, no.
Him and the three guys, like the three guys. Yeah,
Carl?
I'm going to mute Carl.
Thank you. There we go. Someone asked, I think that was you, Terry, if the if I move between each image, and that's exactly what dithering does. What happens by doing that, if I've got hot pixels in my image, which are fixed relative to the sensor, or a dust bunny as an example, when I stack the image is shifted around to line the stars up, and I can use a variety of different forms of stacking that will exclude things based on maybe they're too far out from the average, that sort of thing. And those exclusion stacking methods, when you use those, what will happen is those defects in the image will disappear if you have dithered your images. That answer your question?
Yeah, absolutely. Yeah, thank you.
So now we've now stretched this image, and we've stretched the dim stuff quite a bit. So I'm going to show you something here. If we zoom in on this image, you can see the noise quite easily, right? I'm in the corner of the image now, but even as we get down to the brighter portions, the noise appears to be less. It's not really. The noise is still there, but the signal is much higher. So what happens is the signal to noise ratio is much improved. So what we want to be able to do here now is to take some of that noise down. And what we're going to do that same mask stretching that you saw the last time. So we're going to make a mask. It's a luminance mask. We're going to invert that mask. And what I'm going to do, I'm going to darken the mask up so all this area in here that has all the detail in the image, we're going to make that almost black. And I'm using levels to do that. You could use any stretch, but levels is just a convenient one. So you can see this is black, and most of the detail that's in there is now protected when we do things. But now I have to brighten up the background. So there we go. All the stars are for the most part black, and we'll save that mask. So now what we're going to do, we're going to go back to the zoomed version of this image up here, and now we're up in the top corner. Yeah, well, not quite the corner, but close. What we want to do, we want to smooth all this stuff out. By the way, I was not using an exclusion version when I stacked this, so you can see the hot pixels here, and you notice they've moved around a bit. That's because of the dithering. What I'm going to do, I'm going to use, there's a variety of different noise reduction routines, but like I said, my favorite happens to be the frequency filter. It's just a low pass or a blurring filter, and we'll blur this image. We want to blur it enough to make the background look relatively smooth. So we're just going to wait and see what that does. And it will finish here in a couple of seconds. There we go. It's almost good enough. I'm going to take a little bit more. Again, I'm concentrating on the background in the image. So now it's reasonably blurred. What I'm going to do now is apply that mask that I just made to the image, or to the operation that I just did, I should say. And now we have all the stars back, the detail is in the image, and the background is blurred out quite a bit. So for instance, if we take that off, watch the noise pop up, boom. If we put it back on, watch the noise go away. There we go. And if you look at the image, it's smoothed out. Looks like Quinn is having some trouble there. There we go. You'll notice it smoothed the image out somewhat substantially. We could play around with this image and boost the contrast and do all sorts of stuff with it. But the risk we run is having all these stars bloom substantially. So my favorite technique for dealing with that is, again, to make a starless mask and go back and apply it to that original stretch. So to make a starless mask in ImagesPlus takes a little bit of work. So I've got the mask pre-done, but I'm just going to show you the first step in the work here. You go to the feature mask. You remove most of the stars. You turn up the masked area by a couple of pixels. And then you fill it in. Probably just a little darker there. There we go. Now most of the stars are gone. At this point, you can go in with a clone tool and remove the real bright stars and blur out the background a bit using a mask, and you get a reasonable version of that image without stars. You can now sharpen this image, and I'm going to do it without doing all that other work, and you can bring out detail in here. We're going to do that in just a minute. The technique I'm going to use, I'm going to make a mask of this image as it is. And I'm going to blur the heck out of it. I'll just use a standard blurring filter here, Gaussian filter with a really wide I might even blur it more than that. I'm going to tell it to run that again. There we go. So there is our mask that we're going to use. I'm just going to leave that down here for a minute. I'm going to use another tool now called the multi-scale decomposition tool. Now what this is going to do, this is going to look at this image in a variety of different frequency bands, spatial frequency bands. And it's going to separate it out into all those different components, just like the, Paul, you're a PixInsight user. What's the tool in PixInsight that does that? The multi-scale transform tool?
Multi-scale median transform, I think.
Okay. So this is the ImagesPlus version of, and what it's going to ask me is what filter window size I want. I'm going to pick a little bigger filter window than that, probably up around, say, 79, and do about 20 iterations. This just takes a minute or two. But what I'm going to do, I'm going to take all of the images that it splits out that have any detail at all, and I'm going to combine them into one image. And we should then have just a residual, oops, I'm applying it to the mask, which is not what I wanted. There we go. So it's going to crunch away on that. It's already done 3 levels. And what that's going to do is it's going to combine all those detail levels into one image with detail and one image with sort of the blurry stuff that's in there. And we have to wait till it finishes. It's over half done now. So it actually uses the graphics coprocessor on my laptop for doing this, so it runs quite quickly. In some cases, I'll use 100 iterations if I want to emphasize particular detail. So now we're going to open up the images that produced, but remember, it's only produced 2. Although I use 20 different detail levels, it's going to combine all but one of those detail levels into what it will call the residual or the consolidated, I can't talk. It combines them into this consolidated detail image, and then the average brightness across the image is this residual detail image. We don't want this one. We're going to get rid of this one. Now what we're going to do, we're going to take this image and use the merge split combine mode to combine it with this image. And you can see what the effect is very quickly. Oops. And I just have to tell it not to put the mask in the combine. So we'll get rid of the mask out of here and tell it to apply it. And you can see it's going to produce a very sharpened image, over sharpened, once it finishes here. It's in behind. Display the combination. So here we have the sharpened image. You can see you picked up a lot of detail in the core. Problem is, you also picked up all sorts of crap out here that you didn't want to pick up. That's where the mask comes in. So we take the mask and we apply it to the top layer. And now where the mask is bright, it's going to combine that detail. Where the mask is darker, it's going to leave out some of that. And we could then play with the brightness of the mask. You can see the outside here looks better now. It's not perfect yet, to say the least. But we could then stretch the mask a bit to darken up those outer areas. There we go. And now when we apply it, and we let it crunch for a second. There we go. So now we have some detail in here, all sharpened up. You can see I've even brought out some of the faint red stars across the face here. And we didn't overly mess up the outside stuff here. And then I would go to work and blur this outside area using some masks to remove the last of the lumps. We're not going to do that right now because that takes quite a while to get it right, but I'm going to show you the next part here. We then simply make a luminance mask out of that. So here's the luminance mask. Now, I have stored a mask that I made yesterday while I was getting this image ready, and I'm going to pull that image up.
Sorry, Blair, when you say a second ago that you could go to the outer areas and remove some of the junk,
Yep.
How do you know whether it's junk or actual dark clouds or something?
When I say remove the junk, I'm going to zoom in here and it'll be very obvious. See these circular blobs?
Right.
That's the halos left from the stars that were taken out. That's the junk I'm referring to.
Oh, okay, okay.
And you remove that by blurring it away, but you don't want to destroy the detail down here. So you use a mask on the blur, and it takes a little bit of work to get the mask right.
Right, okay. So even in the outer areas, though, there are those dark lanes that I think may be molecular
Absolutely.
clouds or
There are
something.
dark lanes here, and the blur is not a big enough blur to remove those.
Okay.
Okay, so you can see the effect. I'm gonna pull up a mask that I made here. It's called Brighten. And you can see the final effect. You still have the dark lanes. You have all the detail in the nebula and very little of the noise that was in there. Can you see that now?
Yeah, yeah.
Okay, so that's the final mask that you end up with. What we're now going to do, I'm going to go back and I'm going to remove that, get rid of this consolidated detail thing because that was just to produce the mask. All the work we've done up to this point was to produce a mask from, once it finishes, from this image. Now, when we stretched this image, we got the nebula. There's a little loss of detail here, but the stars are starting to overwhelm the image. They've gotten very bright. Even though it's an Arcsine Stretch, and an Arcsine Stretch is really good at controlling stars, it's not perfect. So you can see it in that image. The stars are starting to overwhelm things. What we're going to do now, I'm going to pull the original version of this image back up. Raw stack, there it is. And this time we're going to apply, I drop that down to 20% so everybody can still see it. This time when we stretch it, we're going to apply this mask to it. What that's going to do is two things. It's going to impart all of this sharpened detail that we put in the mask to the image, and it's going to prevent the stars from bloating. So what we're going to do, we're going to come to here, and we're going to do an Arcsine Stretch. I'm just going to do a little one for the first go around here so we can get it up and running. Then I'm going to take the mask and I'm going to apply it. This time I have to load it. It's called Brighten. I'm going to apply it to the stretch. Slide this out of the way. Now we're going to go back to the Arcsine Stretch and we're going to play with the stretch to bring out all sorts of faint detail, but the stars won't go nuts. So what we're going to do next, we're going to turn the background weight up quite a bit. And I'm going to turn the dim stuff up in the image by a lot more than we have in the past, because the mask will protect a lot of the other stuff. Now you're beginning to see the effect. You notice the stars have not bloomed. You're starting to see all this faint outer dust. Contrast is a little low yet. And we'll even go and slide this up a bit, which will start to bring out all the faint gas and dust. And we can even turn this up a bit. Okay, now the one thing that has happened, you'll notice we've lost some color in the image. That's where these sliders come in down here, remember? We can get some of that red back. A little more of it back. There we go. We can boost the blue a little bit. You rarely have to worry about boosting green. Matter of fact, if you've got a bunch of green in the image you wanted to get rid of, you could actually slide that slider the other way. Now take a look. Look at the difference in the amount of detail in the core here versus the simple stretch. And notice that the stars are really, really well controlled, perhaps a little too well controlled in this case. I might want to brighten that mask up a bit to actually get some more of the stars back in, but you get the idea. The mask has given us an image that has all sorts of detail with very little distortion on the stars. Matter of fact, take a look at what the stars look like at the corner of the frame. Right? Take a look at the stars at the corner of the frame in the simple stretched version. You'll notice they're quite bloated compared to same stars right there. We may not actually be looking at the same spot there, bear with me. We're not, 1 sec. Opposite corners. There we go. So look at the difference in this star. The halo is starting to distort a little bit. Here it's pretty round. As you get down here, these stars are quite big. Look at them here. Not only that, even though we have applied smoothing to this background, there's still noise in this background. Look at the background in this image. All because of that mask that we used on that first initial stretch. Now you can go to work. This image is probably the better part of 80% of the way to complete. You can now go and do all sorts of interesting things to this image to sort of finish it off. I'm going to close down the simple stretch version. We can, I can get my mouse to stop moving. There we go. We can brighten up certain parts of the image just a little bit more. Expand the contrast a little more. Now we're starting to see all this gas outside here in those dust lanes, right? And so I'm probably done with the initial stretch on that image at that point. Now there's a really simple technique to make this pop quite a bit. What we'll do, we'll duplicate the image. By the way, this works on Photoshop as well for those that are Photoshop users. And all I'm going to do, I'm going to up the brightness and contrast of that image. So we'll up the brightness a bit. And then I'll up the contrast a bit. And now you're starting to get, as far as the core of the nebula is concerned, a decent looking image. There we go. Problem is now you lost some of the outer gas and dust. You might be okay with that. It might not be too bad. But what we would really like to do is combine the outer areas of this image with the bright areas of this image. And you actually do that. And it's an old technique that Photoshop used to use, or that Photoshop users used to use, I should say. And we'll do the same thing here. What we're going to do is we have two images. Once the combine finishes here, because I have to find out which is on top. Okay, so the top image right now is this one, and we actually want that to be the bottom image. So we'll just slide it down in the image stack. Now we're going to take a look at this image. And what we want to do, we want to make a mask out of this image, which is easy to do. Make a luminance mask. And all I'm doing here is I'm using a layer combine, in case anyone is curious. Then I'm going to blur that mask substantially. I have to remove all of the detail from that image. Maybe even more than that. There we go. And repeat that one more time. Maybe even one more time. You really want to blur as much of the detail out as you can. There we go. We're going to use that as a mask on that top contrast enhanced image. And now watch what happens. There we go. Oops, I didn't do it quite enough yet. Wait for it. May have to break. There we are. So now we have an image that has the contrasty central part and all of that nice gas and dust in the outer part, and the stars have brightened up just a little bit. It's sort of now ready for the final contrast and sharpening. And I think you got an image of M8 that's worth keeping.
Blair, would you want to boost the saturation at all?
Actually, what I want to do first, before I boost the saturation, I'd actually want to shift it toward red just a little bit, but I won't do that until I've got it looking the way I want. The reason for that is when you shift the color and boost the saturation, it can up the color noise. So you really want to have the image sort of at its final contrast before you do that. So now we'll take this image, and I can apply any one of a number of tools to sort of get the contrast finally where I want, but let's just use some curves here. That might be a little too much. It's not looking too bad, at least on my screen. And then we probably want to sharpen it up just a little bit. There's a variety of sharpening tools. Again, you could use adaptive Richardson-Lucy deconvolution, but I'll just do a simple and then maybe emphasize the medium a little more. There we go. Now starting to get a little sharper. Now it's not, color is very subjective, and astrophotographers or image processors go nuts with this concept of true color. All you have to do is talk to Roy Bishop, and he will very quickly convince you there is no such thing. Color is a function of the human eye and brain. It is not a function of nature. Nature will give you a spectrum. Your eye sees color from that spectrum. So chasing true color is a bit of a waste of time. I tend to make my images simply look the way I want. Close some windows here, bear with me. So I would take this image personally and shift it a little bit toward the red or magenta. And there's a nice tool for doing that here called the Selective Color Balance tool. We'll put a little more red in the image. Again, tiny adjustments, not big adjustments. That might be too big of an adjustment. And then we'll just dial a little blue in to make it a little more magenta. That's not too bad. So there's sort of the decent color in the image. And then finally, what I would do with that image, I would crop it to get rid of the stacking artifacts. And then finally set the background levels. So we go to the levels tool. You can see that the background can be taken down a little bit here. There we go. Maybe a little too much. This one is subjective and very monitor dependent, but at any rate, there we have an image of M8 with really good detail in the dust lanes in the core, relatively low noise, and we still have this faint odor envelope of the nebula going up here and over on this side. We could change that stretch and bring that out a lot more, but it's a little bit outside the scope of how to do that just yet. But that's all done with creating a starless mask and applying it to your initial stretch. It keeps everything under control and imparts the detail that you put on that mask to the final image. Any questions? None?
If you look at the histogram, your brightest levels, there's a little spike on the very brightest level of all. Is that an artifact that you created, or was it in your original?
It's not an artifact as such. Well, I guess it's sort of an artifact. What that is as I stretched it, some of the stars saturated. So you can see a lot of these stars are white here. That's this peak. So there's lots of pixels at that value is what it's telling you. It did, however, keep a lot of the stars. You'll notice there's lots of red small stars throughout the image. Right there, all down there. So it keeps a lot of detail. There's no noise in the background, and look at the detail in the nebula. Right, all because we used that original starless mask that we had sharpened and noise reduced and put all that detail in. I mean, look at the core of that nebula. Anyone that's processed M8 before knows that that core blows out very, very easily. Here we were able to avoid that.
Yeah, no question. It really looks good. That's for sure.
Fantastic.
Go ahead, Bob.
No, I'm just soaking it all in. Thank you.
I have a couple of pages on my website that have papers on how to do this. So anyone that's got ImagesPlus there, don't worry too much about going nuts trying to take notes. They're covered on my website. There's a couple of PDFs there on how to do mask stretching and split star processing. We could do some funny things to this image as an example if we wanted to shrink this down again here. Oops. So let me close down that original one. So now we've got the image right here. If we wanted to really make that nebula pop as an example, maybe even a little too much, but just as an example of how you can do this, if we go to the feature mask tool, again, take the stars out of that image. That didn't do too bad a job. Maybe dial that up a little. What I'm looking for is to make sure that I haven't taken out parts of the nebula and just stars. It looks pretty good there. And we'll just darken that up a little bit. So we should have lots of halo. Even the halos are pretty much gone. So we'll split the stars out of that. So now we have the stars and the, there's the stars, and the background or the deep sky object. What we're going to do now, we could sharpen this up and boost the contrast of this, and then put the stars back in, and the stars don't blow out. So to give you an example, we'll use the multi-scale decomposition tool again, but this time I'm going to use a window that is quite big, let's say almost 200, and we'll use about 30 passes. Now this is going to take a second. And what it's going to do, it's going to make a version of this image that has all sorts of detail and then a very blurry residual image. And we could do it to the original image that we started with, but the problem would be that all of the stars would end up saturating when we use it to sharpen the image. Here there are no stars, so the stars are going to be much better controlled, and we'll use a mask on top of that to control what happens.
Let me ask you, Blair, while that's crunching, is there any sort of subgroup within astrophotographers that actually likes making galleries of these images with the stars removed?
There are a bunch of people that do that. typically what they do is they make an image the way they want it with stars, and then they might post one without stars just so people can see, you know, here's what the nebula would look like if all those pesky stars weren't in the way.
Okay.
And this has finished. So again, we're going to open all the levels. So here's that blurry image that's nothing but the sort of average brightness across the image again. And here's the nicely detailed version. And we're going to combine this with this using that special blend mode that's built in ImagesPlus, which is called Merge Split. It's a blend mode that's not in, to my knowledge, any other software package. I want to remove the stars from that. So there we are. And you can see what's going to happen. When I do this, it's going to produce a nebula image that has way too much contrast. It'll probably be blown out a few areas, but we'll let it do its thing here. So you can see the core is quite blown out, but look at the detail in here. So now if we make a mask of this, actually, sorry, not that, a mask of the original, simply because its core is not as bad. And again, we're going to blur that mask substantially. And we're going to put that mask on the top image. That should help control some of that blowing out that you saw. Still a little bit blown out there. So what we would do is we go into this mask and darken this area. And the simplest way to do that is use a curve adjustment. Oops, that's under stretch. And what we'll do is we will turn down the brightest parts in this image. And we'll tell it just do it to the bright spots. So we'll slide this up a bit. And all I'm attempting to do here is dim that core a bit. There we go. So that's not too bad. And then we'll reprocess that. And now let's see what we got. Oops. We can then dial down the opacity just a little bit. Try and get some of that core detail back there. Might even have to darken the mask a little bit more. Actually, what we'll do, we won't darken it anymore. We'll put it back in from the original image. So we'll wait till that finishes. Okay, so now we have that wonderfully detailed nebula. Flatten that. But you notice the core has blurred out just a little bit. We brought up all sorts of faint red stars throughout the image as well. I'm going to get rid of this mask for a minute. And what we're going to do, we're going to take this core, this central core area out of this image and put it into this image. So what we'll do is we will now stack those images. And we'll just use a normal combine this time. Again, this is all the same sort of processing you would do in Photoshop. Delete that image, delete the stars. And I have to make sure I got the right image in the right spot here. That's the one. So what we're going to do now, I'm going to make a mask out of this image and just paint this area white. Actually, I'm sorry, I'll make the mask out of this image so I can see where it's blown out. There we are. So now you can see where this image is blown out. I'm just going to dim that, make that mask luminance. And I'm going to dim the image just a little bit so that I can paint the area that I want. I don't have to dim it much. I just have to make sure that nothing is saturated. There we go. Then I'm going to take a paintbrush And I'm going to paint it at a maximum value for my 16-bit image. And I'm going to paint out this whole core area, the part that's saturated here. It should end up white. I could use a bigger brush, but if you use a bigger brush, you run the risk of painting over something you don't want to. So bear with me just a minute. There we go. Now what we'll do is use the thresholding operation to get just that white area that I painted. There's my mask. We'll end up blurring that in a minute, and I'll show you why. It's sort of the next, oops. There we go. I just have to close an operator here. There we are. Okay, so now what we're going to do, we're going to put that mask on the top image. Now remember, the bottom image is the real sharp one with the blown out core. The top image is the original one that has detail in the core, but it's not as sharp everywhere else. And we're going to combine the core of this one with the detail in the bottom image. And we'll do that by using this mask. Wait till it comes up here. So now you can see we've got all of this wonderful detail out here, but the core is preserved. There is an abrupt, if you could see it, there's a fine line here that's quite abrupt. It's because the mask is abrupt. And all you do is you blur that mask a little bit and that line disappears. So if we take that mask and blur it a little, maybe a little more than that. That's pretty good. And then we apply it. Now look at the image we've got. Look at the detail in the nebula. Core is still preserved. All we have to do now is put the stars back in. So what we'll do, we'll flatten this. Close some of these windows that aren't needed anymore. So compare this enhanced nebula image with the one we started with. Look at the detail difference all around here and up through here compared to the original. Now all what's left, as I said, is to put the stars back in, and we'll do that by combining the two images. This one, which is the star-only image, maybe I'll go even smaller here so it's easier to see. There we go. With the nebula image that has been enhanced quite a bit. So now we'll combine those two. And it's usually smart enough to put the stars on top in the image stack, and we'll see what comes up. And there we are. Take a look at that image. The detail you get in the nebula, and the stars aren't blown out. You've got all sorts of detail in the core here that you didn't have before, or at least it wasn't as obvious. And that gives you an idea of how you can use the feature mask tool. I'm going to go back on this. Might not be able to. No, I can't. That gives you an idea of how you can use the feature mask tool to make an image that has very low background noise, because we used a mask when we stretched it, and the mask had been noise reduced, and has spectacular detail throughout the nebula. Take a look at that.
Yeah, it looks spectacular. Let me ask you, Blair, are these original images ones you took with your refractor?
Yeah, this particular one was taken with my refractor and my camera at St. Croix.
So if a person was using a reflector with a secondary mirror, would you have additional steps to remove the flare lines from the bright stars?
Most people don't bother removing them. They're not usually that bad. Bear with me a minute. I will pull up from my web page. I think I have one of those. If I can pull it up here, I can share the web browser. Oh, Greg Trump's face comes up. I can share the web browser and give you a look. I think I have an M8 image that was taken with my reflector. I think. Yep, there we go. So here's an image. Okay, I have to switch screen shares, so bear with me a second. I got to stop the share on that screen. And I have to share this. So there you can see the star spikes you're talking about there, Terry. They don't generally look too bad. So most people just leave them in.
Okay.
Okay, I'll flip that share back now.
If you're taking quite a few exposures over a long period of time, will they not rotate in the image plane?
Nope. The telescope, as it tracks the sky, the whole system rotates to match all that. So as a result, you don't see any rotation of those at all.
Okay.
As I was zipping back and forth here, once I get this shared back here, there we go. As I was zipping back and forth, I saw there were a couple of chats that had opened up with people asking questions. If you don't mind, I don't see the chat window when I'm sharing my screen here. Please turn on your mic and ask the questions. I'll happily answer them. Or Jared, if you get a second, if you could read them out loud so people can hear them.
Just real quick, Blair, when he was talking about a reflector, would that be like an SCT?
An SCT is a reflector, but it does not produce those star spikes. Those star spikes come from the, it's called a spider, the two crossed metal pieces that hold the secondary mirror in place on a Newtonian.
Thank you.
Yep.
So Matt had asked at 8 o'clock, is this the process for most images so you can tweak both the foreground and background separately? Was it largely, in this case, just due to the banding?
Okay, he was talking about the M13 image, and I think I've answered that by processing this image. It's the workflow that I generally use for almost everything. It allows me to really control the stars in the image and make what is to me a better balanced image. If you happen to like lots of stars in the image, don't do it, but I tend to like to suppress them a little bit, as you can see.
I'm glad we've got this recorded.
Yeah. Any other questions on the list there?
No, there are no other questions.
Okay. So that sort of gives you an idea of how I tend to go about using ImagesPlus. I've only touched on some of the tools. There are tools to do all sorts of stuff. If there was a gradient in this image, there doesn't happen to be one, but I could remove the gradient in a couple of different ways. I can tweak the color. So for instance, if I want to set this point up here as black, as an example, I just click Neutralize Background and click on that point. And now that is black, and it shifts the color in the image to make that point black and everything else fall where it may, so to speak. You can do the same for the white point or the midtone. You can make the midtone gray.
One thing to note, Blair, I guess, is that this isn't your standard Dlsr camera, right? That you started this image
This
with.
particular camera is not. It is my 60DA. There's not, I'm not going to say there's not a lot of difference. There certainly is. It's got much better red sensitivity, but that doesn't mean that a stock camera has no red sensitivity. You can actually add the red in processing to sort of make an image from a stock camera look like this. Somewhere, if I can find it, I have, bear with me a sec. I may have to flip the share on my screen here in a minute. I have an image of M8. I don't think I have it on my website. I have an image of M8 taken through my old unmodified camera. And I can't find it here at the moment. I do have an image of M42. No, that's an urban image. Oh, wait now. Lagoon. There we are. Now, keep in mind, this image is from long ago with crappy optics on my old Meade Schmidt Newtonian. It's an unmodified camera, and it is not processed using ImagesPlus. It was processed using PaintShop Pro. And taken long before my processing talent was up to the challenge, but it'll give you an idea of what an unmodified camera can produce. So let's see here. I should be able to do that. Can everybody see that?
Mm-hmm.
So you can still see there's lots of red in that image, even though it was a stock unmodified camera. There's also lots of star bloat and distorted stars and everything else, all of which I would now fix. But since I just left that up there to give people an idea of the difference between a modded and unmodded camera. So you've got an image that, keep in mind, we're just looking at the red here. There's the nebula versus this. So you can see there's lots more red in the background, which is where most of it shows up. And again, I would bump the contrast up on this one step more sort of as the final processing, but you got lots of detail in it now. That's the other nice thing about not bloating the stars too much, is you don't have to push the stretch as far to see the nebula. It makes the nebula, at least to my eye, look a little more natural. It doesn't have abrupt transitions. So you notice it doesn't go right to black immediately after here, like you'll see in a lot of images. You still see all this gas and dust down here, but the nebula still pops out. Again, that's just a personal image processing style that I like, but hey, what can I say? Any other questions?
Is this type of processing sort of similar in concept to what terrestrial photographers do in HDR?
To some extent, but it is done differently. In HDR, some of the steps I used are the way you do HDR processing on astrophotos. For instance, when I put the core back in from the other shot, that's sort of an HDR process. But the idea of splitting the stars out, splitting the foreground out from the background, so to speak, is not, strictly speaking, an HDR type of processing. Bob, you had a question coming up there.
Yeah, I'm assuming that this is your go-to processing software.
It is. There's lots of good software out there. PixInsight is another package that does really well. I tend to find personally that PixInsight doesn't have a workflow that I like. I like a more Photoshop-like workflow, which this package has. It has layers, masks, and blend modes, along with some very nice features for pulling data out of the images.
The learning curve steep?
The learning curve is always steep, no matter which package you choose. Even Photoshop and PaintShop Pro will have relatively steep learning curves, at least when you get into the details of how to combine layers and use masks and that sort of thing. This one probably has a gentler learning curve than PixInsight and a steeper learning curve than, oh shoot, what's the name of it? AutoStars, I think, is the name of the package. It's sort of a one-click package. You know, you click on a couple of different things and it does a whole bunch of stuff behind the scenes. Very good at getting an image about 70% of the way there, and then you sort of work with it from that point. Again, it just depends on the way you like to work.
Okay. Last question. Obviously, it's Windows only. There's no Mac version of this.
That is correct. This one is Windows only.
Okay.
You can run it quite happily in your favorite Windows emulator on a Mac. It does work quite well.
Okay.
I don't know if it lets you use the graphics coprocessor that way to speed things up, though.
That should be a function of the emulator.
I would suspect so.
It should present that. Yeah.
I can tell
Okay.
you it doesn't run quickly.
No, and that was the other question, Jerry. I'm used to using Fusion on an iMac, so if you give it enough, it'll run, but you got to give it a fair bit.
Give you an idea, the images we're working with here tonight are, does it tell me the size? When I say size, I mean the number of megabytes.
Yep.
It's about 5,200 pixels before I crop it,
That's about
by about 3,300 pixels.
okay.
And they generally run as FITS files in the order of 100 megabytes or more. And the machine I'm doing all this processing on tonight is an i7 quad core running at about 2 to 2.2 gigahertz. That will, when it needs to, flip up to 3.2 gigahertz, and there's about 8 gig of RAM on board. I could use more RAM, but it's a reasonably potent processor.
Yeah, I traded that off for RAM, so that's good.
Doing image processing, having lots of both comes in handy.
Yeah.
You will never complain about having a fast processor, and you will certainly never complain about having RAM.
Well, I like the idea of using the Mac simply because I prefer the interface, but it's also a much better screen. My laptop, I've got a laptop with Windows, and it's
yeah. I
up
tend
to
to
this
do
job.
all my I tend to do all my processing on my laptop, and I've calibrated the screen so it does quite nicely. But I do have a very nice monitor downstairs that I use from time to time if I'm really struggling with some color.
Thank you.
Blair,
And-
talking about hardware, does a solid state hard drive help at all?
If you haven't, Jerry's got his thumbs up saying yes. The simple fact is, if you have enough RAM, no. But if you don't have enough RAM, a solid state hard drive is a good thing.
It's certainly quite useful for PixInsight.
Yeah. Yeah, if you have to do a lot of buffering to disk, then the solid state hard drive is a little quicker. Any other questions? I saw one more pop up there. I'm going to stop sharing my screen here so I can get my video window back up, and then I can see some comments. There's one question from Matt Dyer. I don't know if he's still on the list. Do they make image processing specific graphic cards like they do for 3D gaming? No, they don't that I know of. Generally, we use the 3D gaming cards. They tend to have really good cell processors, which is what this package in particular is really good at using. Let's see. Dave Hoskins said, thanks. Unfortunately, I use Photoshop, and then he had to leave. We are going to do a session, hopefully, on Photoshop. Much of the techniques that I showed here tonight using layers, you can use in Photoshop as well. There are plugins for Photoshop that will let you do a lot of what I showed tonight. And with the use of StarNet++, you can even make those starless masks and still use them in Photoshop. I think that was everything in there.
Blair,
Yeah.
I was on the website for ImagesPlus, and I see there's basically two different versions that are about $40 different. One says camera control, one doesn't. You know what the difference is
Yes.
between those? Is that like a image capturing?
Yes, it is. The one that says camera control includes ImagesPlus camera control. Don't bother. Mike is, I don't think, even supporting camera control anymore. It became such a pain in the butt trying to support it because DSLRs keep changing all the time that you just want to get the processing package. There are better packages for camera control out there.
Awesome. Thank you.
Any other questions?
That looks good. Thank you, Blair.
Well, no problem. That'll give you an idea of some of what ImagesPlus will do. Assuming I can tap him to do a Pix Insights session, we're going to try and get Jeff to do one of those in the not too distant future. Give people a walkthrough of Pix Insight and some of its functionality. I'm not sure who I'm going to try and tap to do the Photoshop session. I can do a Photoshop-like session, but unfortunately I use PaintShop Pro for that. So the interface is a little different, although all of the features are the same. So we'll see if we can't find someone who uses Photoshop to give people a walkthrough.
Maybe David Hoskins.
Possibly, although I know David Hoskins wants to attend a Photoshop session so he can find out a bunch of stuff. What we might do is get David to do a session, and maybe I can sort of present some techniques that work both in ImagesPlus and Photoshop, and then he can do them in Photoshop as well.
Listen, Blair, thanks a lot.
You're more than welcome. Any other questions out there before we call it an evening? We're actually finishing an hour early.
Well, I would echo that comment. Thank you very much, Blair. It's always something to sit and listen and try and absorb. But I'll tell you, the buffers overflow, and I'm glad that we got this recorded.
Yeah, I will make the offer to anyone out there that if they have a question on processing in general, ImagesPlus in particular, don't go banging your head trying to figure it out. Just give me a ring or drop me a line. I'll happily answer it. One resource that is out there that I would heartily recommend people use is I'm actually a moderator on it. There are 4 of us that are moderators on a Groups.io list called, what is it called? DSLR-image, astro-image-processing. And what it is once every couple of months, we share some raw data, calibrated and stacked data, I should say, and everybody works on the same image. The advantage there is you get to trade tips and tricks on processing, and you also get rid of the problem of wondering whether you're not getting good results because your captured data is not good, because everybody works on the same data, trying to get the best they can out of the data that's made available. Most of the time, some of it's my data, some of it's other group members' data. It's not always spectacular data. The idea is to get the best you can out of what you've got to start with and share how you went about doing it. It's a great way to learn image processing and get tips from people. It's also a great way to find out whether it's your raw data that's the problem or whether it's your processing technique.
Yep. And that's needed. Can you repeat the Groups.io name? DSLR.
It is one second. Let me look it up here so I give it to you properly.
Maybe you could type it in the chat.
Yep.
Oh, is it in the chat?
No, not yet.
It isn't yet. It's fairly straightforward, actually. It's DSLR dash astro, ASTRO, dash image dash processing at groups.io. And if you go to groups.io, type in DSLR dash astro dash image dash processing, it will take you right to the group. You do have to sign up for the group. When you do, I'll get an email and I will very quickly authorize you to post to the group. Typically, like I said, once every couple of months, usually about once every 2 months, we'll process a challenge image. It used to be a Yahoo group. I see Glenn just joined us. Hi, Glenn. It used to be a Yahoo group, and Yahoo has pretty much dumped support for groups. It's only on a message board now. So we moved over to Groups.io. There used to be about 1,500 members. There's probably several hundred now that moved over, and others are moving slowly over time. Usually what happens is they'll post something to the Yahoo group saying, how come there's no activity here anymore? And I'll answer them and say, because it's all over on Groups.io, and then they'll move over.
Okay, thanks, Blair.
You're more than welcome. Any other questions? Okay, well, at that point, unless anyone's got any other questions, we'll call it an evening. Jerry, you started recording the session?
Yes, I have a recording underway, so it might take me a day or two to re-render it. And we'll talk, I guess, about where you would like it and how we're going to present it.
Okay, one thing we will do, and I'll ask everyone that's still here before you leave, since we did not tell anyone that this could be recorded, is everybody okay with the fact that we've recorded it and we'll be posting it to the center website somewhere?
Absolutely, yeah. Thanks, guys.
Okay. If there's no one saying nay, then I would suggest that is permission to do so, Jerry.
Great. Okay. Thank you.
Okay. Any other questions? Okay. Well, we will do another one of these on ImagesPlus, certainly, and I'll go through some of the other functions like deconvolution and those sorts of things. What I wanted to do tonight was to present the user interface, let people get a look at it, and also present the idea that's sort of key to the way you use it, that you actually process images in, you don't process them as a whole image anymore. You tend to process them as background and foreground or various levels of detail. I didn't get too much into that, but we did use, for instance, the multi-scale transform tool. There are other ways of using that tool, and we'll look at some of that as time goes on. We'll do a couple more of these sessions. Okay, good night, everybody.